So this is lesson 3 of the topic 4 of Edexcel GCSE Combined Science topic, and it's on oxidation and reduction, and it's a bit of a summary of what we've studied in lessons 1 and 2, and it just ties everything in together. So just to recap then, oxidation and reduction so far we've said is oil rig. Oxidation is loss of electrons and reduction is gain of electrons. Also we said oxidation is also gain of oxygen and reduction is loss of oxygen. And in the last lesson we said that metals can be extracted from their ores by reduction with carbon, and there would be a metal extracted from its ore by reduction with carbon means the metal is reduced. So you can look at the previous lesson and you can answer this question: where do metals come from? Suggest where metals we use come from, and you should be able to give examples of metals that are extracted using carbon. Here's a nice little homework task which you can do in your own time using the internet or BBC Bitesize. You can look at different metals: aluminium, nickel, zinc, iron, how they are extracted from their ores. Okay, there are two main ways of extracting metals. Number 1, reduction with carbon. Number 2, electrolysis using electricity. Last lesson we looked at reduction with carbon. Today we will focus on extracting metals using electricity, which is known as electrolysis. Electrolysis will focus on the most reactive metals. The reactivity series helps us to determine which metals are extracted using carbon and which are extracted using electricity. So oxidation reduction in terms of oxygen, again this is a recap. Oxidation is gain of oxygen, reduction is loss of oxygen. And a redox reaction is a reaction where oxidation and reduction occurs simultaneously. In the same reaction, something is oxidized and something is reduced. Okay, now let's look at this then. A metal oxide, like iron oxide we looked at in last lesson, if that is reduced to produce a metal, that is a reduction. Here, let's use a different example. Lead oxide, PbO, reacts with carbon to produce lead and carbon dioxide. So let me just highlight for you. Lead oxide contains oxygen. It produces the lead. Lead has lost an oxygen, so that is reduction. Carbon is uncombined and it forms carbon dioxide there. So carbon has gained oxygen, or carbon is oxidized, lead oxide is reduced. This is an example of a redox reaction. That's the best way. Pause it here. Just go through this slide again in order to understand reduction happening and oxidation happening in the same reaction. Okay, and there's a sentence that explains what has happened in this reaction. So oxidation is gain of oxygen. Carbon became carbon dioxide, so carbon is oxidized. Lead oxide became lead, so lead oxide is reduced. Question: how is iron extracted from iron oxide? Write a balanced equation for this reaction and identify what is oxidized and reduced. Again, it's a question for yourselves in order to attempt this. Okay, now let's look at extraction using electrolysis, and the example will be extraction of aluminium. Just a quick recap then of the reactivity series. Please note here something important. The word molten means liquid state. We can't extract metals from solids. So the metal compound needs to be molten. It needs to be melted. So we will heat it first in order to melt the compound. So aluminium oxide is the ore. It is molten. Aluminium oxide will be dissolved in something called cryolite, and then electricity will be used to extract aluminium oxide. Carbon is less reactive than aluminium, hence carbon can't be used to extract aluminium. The reaction is aluminium oxide forms aluminium and oxygen. Balanced equation, very important. Please remember the formula of aluminium oxide, Al2O3, and this is the reaction that occurs in the electrolysis in the extraction of aluminium. We have like a metal casing, a steel cell. We have a negative electrode, which is the cathode. We have a positive electrode, which is the anode. And you don't need to know all of these conditions, by the way. Aluminium contains those. Aluminium 3+, just to recap, aluminium is in group 3. It can lose 3 electrons to become Al3+. Oxygen is in group 6. It can gain 2 electrons to become O2-. So aluminium ions are positive. They will go to the negative electrode where they will gain electrons, and oxide ions of oxygen ions are attracted to the anode, to the positive, where they will lose electrons. So the reactions are the following. At the cathode, just to go back a bit, the electrodes are made from carbon, and because carbon reacts with oxygen to form carbon dioxide, so the electrodes have to be replaced regularly, and that also adds to the cost of extracting aluminium by this method. Okay, the reaction at the cathode is Al3+ plus 3 electrons forms aluminium. There's no harm in putting a negative sign here on top of the aluminium. And at the anode, O2-, remember it's O2, therefore you need 2 O2-, and there are 4 electrons produced on the right. So here can you see gain of electrons, that's reduction, loss of electrons, oxidation. And also oxygen is formed, a good sign of oxidation. Next, what is corrosion? Corrosion is the destruction of a metal due to reactions with other chemicals in its environment. Corrosion happens when a metal reacts with oxygen. So metal is oxidized. So corrosion is the oxidation of a metal. And the difference between corrosion and rusting. Rusting is a special form of corrosion of iron. Iron rusts. You could say iron corrodes. Corrosion requires oxygen and water. So for iron to rust, you need oxygen and water. The more reactive the metal, the more rapidly it corrodes. Gold does not corrode. Hence, gold is valuable, used in jewelry, but it will not corrode. Do all metals corrode? No, not necessarily. The metals at the top of the reactivity series like potassium, sodium, calcium will easily corrode because they will react with oxygen much easily. The metals at the bottom like silver, gold, platinum, precious metals, they do not corrode and will not react with oxygen. As I said, rusting is the corrosion of iron, and you do need to remember this equation. Iron plus water plus oxygen produces hydrated iron oxide. This is that brownish substance which forms on top of iron, which we call rust. The opposite process where oxygen is removed from a compound is known as a reduction. So the reverse of this reaction would be reduction. So acid, rain and salt can increase the rate of rusting. And that's it for that topic of oxidation and reduction. Thank you.